In this example, we are going to graph transformations of the sine and cosine functions. So those would be functions that look, for example, like a times sine of bx plus c plus d, where a, b, c, and d are just constants. So remember that the absolute value of a, that coefficient out in front, is what's called the amplitude, and that's a vertical stretch factor. And then this number b determines the number of cycles inside of 2 pi. So your normal cycle length without a multiplier is 2 pi. Divide that by the absolute value of b, that gives your new cycle length. And then your phase shift, which is a left-right shift, is going to be controlled by both of these numbers, b and c. Your phase shift is negative c over b. The reason for the negative is because these are inside the sine function. And remember, horizontal shifts work in opposites when they're inside the function. So in this example here, we've got y equals 3 sine 2x minus pi minus 1. So let's go ahead and identify our coefficients here, and then we'll find the amplitude, cycle length, phase shift, and graph. So A is our multiplier out in front, which is 3. So this is going to be the sine graph with a vertical stretch of 3. Our B is 2. So that's telling us that there's 2 cycles inside of 0 to 2 pi. And then C is going to be negative pi. And then D, which is our up-down shift, is negative 1. So first our amplitude, which is absolute value of 3, or 3. Cycle length, 2 pi divided by absolute value of b. So 2 pi divided by absolute value of 2, which is pi. So this graph has cycle length pi and then repeats. And then our phase shift, negative of c has got another negative in it. Negative pi over b is 2. That double negative is going to make a positive pi over 2. So we're going to shift pi over 2 units to the right. So I'm going to go ahead and graph this in stages here. So a normal sine graph would have cycle length 2 pi. It would go up to 1 and down to negative 1. So that would look like this. So first, let's adjust the amplitude. We'll actually do these in order: amplitude, cycle length, and phase shift. So the amplitude adjusted to 3, so it's going to go up to 3 and down to negative 3. But everything else stays the same. So that is the graph of 3 sine x. And the blue we started with, that's sine x. Next, we will go ahead and do our cycle length adjustment. So now instead of going out to 2 pi, it's only going to have a cycle length of pi. But still going to go up to 3 and down to negative 3. So it's going to hit in the middle at pi over 2. So it looks something like this. So that is going to be the graph 3 sine 2x. And let's see, that's, yes, 3 sine 2x. So we made the cycle length adjustment. And now the phase shift plus pi over 2. Let me do that one in green. So what we're going to do is take this point and move it pi over 2 to the right. Pi over 2 is right here. Right, this is pi over 2. So this point and this one and this one and this one and this one all get shifted pi over 2 to the right. So this one goes to here, that one to there, this point gets shifted to here, this point to here, and then this one to right here. So it's now going to look like this. And that is going to be your 3 sine 2x minus pi. And then the last thing we do is down 1 unit. So that -1 on the end is just going to shift things down 1 unit. So we're going to take these 5 points again and shift them down 1 unit. So here, and then this point down 1 unit there, this point down 1 unit right there, this one down 1 unit, and then this point down 1 unit. So one cycle of our final graph looks like this. So that is y equals 3 sine 2x minus pi, and then minus 1. And then if we want to double check this on the calculator, I've already entered that in there. Make sure that you are in radian mode. So go to mode and make sure this is radian and not degree, and then click our graph, and there's our graph. Scale of 1 this way, scale of 1 this way. So you can see 1, 2, 3, cycle length of pi. You can see it goes between 2 and -4. That is indeed the graph that we have here, the black graph right there.